This video is about binomial expansion without calculator. In the expansion of x plus k to the 7th power, where k is a real number, the coefficient of a term in x to the 5th power is 63. Find the possible values of k. This is the general term for binomial expansion. X plus k to the 7th power, n equals 7. General form, 7 choose r times x to the 7 minus r's power times k to the r's power equals 7 choose r times k to the r's power times x to the 7 minus r's power, x to the 5th power. So we need to set up this exponent. 7 minus r equals 5, r equals 2. This coefficient of x to the 5th power is 7 choose 2 times k squared equals 63. We know for this combination equals reduce n times n minus 1 times n minus 2 times n minus r plus 1 over r factorial. So 7 choose 2 equals 7 times 6 over 2 factorial equals 21. 21 times k squared equals 63. Divided by 21 both sides. K squared equals 3. So k equals plus or minus the square root of 3. 2a, consider the expression 1 over square root 1 plus ax minus the square root 1 minus x, where a is rational numbers, a is not equal to 0. The binomial expansion of this expression in ascending powers of x as far as the term in x squared is this, where b is rational numbers. Find the value of a and the value of b. We will change this into exponential form. 1 plus ax to the negative 1/2 power minus 1 minus x to the 1 over 2nd power. Since exponents is not positive integers, we need to change this a equals 1. Then we have 1 plus b to the nth power equals 1 plus n choose 1 times b plus n choose 2 times b squared. We stop here because this is x squared equals 1 plus n times b. N choose 2 will be n times n minus 1 over 2. 2 factorial is 2 times b squared. 1 plus ax to the negative 1/2 power. We know b equals ax, n equals negative 1/2. So we plug into this formula. 1 minus 1/2 times ax plus negative 1/2 times negative 1/2 minus 1 over 2 times ax squared. Simplify. 1 minus 1 half ax. Move this 2 to the front, plus 1 half times negative 1 half times negative 1 half minus 1 is negative 3 over 2. A squared x squared. Simplify 1 minus 1 half ax. Negative negative will be positive. Numerator is 3. Denominator is 8. A squared x squared. For second binomial expansion, 1 minus x to the 1 half power equals b equals negative x, n equals 1 half. 1 plus 1 half times negative x plus 1 half times 1 half minus 1 over 2 times negative x squared equals 1 minus 1 half x plus move this 2 to the front, 1 half times 1 half times 1 half minus 1 is negative 1 half. Negative x squared is x squared. We do know negative x to the 2nth power equals x to the 2nth power. 1 minus 1 half x minus 1 over 8 x squared. So 1 plus ax to the negative 1 half power minus 1 minus x to the 1 half power equals 1 minus 1 half ax plus 3 over 8 a squared x squared minus, remember change sign for these algebraic expressions, minus 1 plus 1 half x plus 1 over 8 x squared. Combine like terms, these two take x out. 1 half minus 1 half ax, then plus 3 over 8 a squared plus 1 over 8 x squared should be equal to this, equals 4bx plus bx squared. Coefficient of x will be equal to each other. The coefficient of x squared will be equal to each other. So we set up this system equation. 1 half minus 1 half a equals 4b. 3 over 8 a squared plus 1 over 8 equals b. First step, we need to get rid of the denominator. Times 2 both sides, 1 minus a equals 8b. Times 8 both sides, 3a squared plus 1 equals 8b. Both equals 8b, so we can get 1 minus a equals 3a squared plus 1. Negative a equals 3a squared. Negative 1 equals 3a, so a equals negative 1 over 3. Then we plug back into this equation. We can get b. 1 plus 1 over 3 equals 8b. When you solve any equation, just make sure get rid of the denominator times 3. both sides. 3 plus 1 equals 24b. 4 equals 24b. Divided by 24, both sides. b equals 1 over 6. So a equals negative 1 over 3 and b equals 1 over 6. 2b. State the restriction which must be placed on x for this expansion to be valid. Only absolute value of b less than 1 that make this expansion valid. So for these expressions, we have two expansions. The first expansion, we have to make absolute value of ax less than 1. For the second expansion, we have to make absolute value of negative x less than 1. We need to solve these two inequalities. A equals negative 1 over 3. So we have absolute value of negative 1 over 3x less than 1. We do know absolute value of negative x equals absolute value of x. So we have 1 over 3, absolute value of x less than 1, times 3 both sides. Absolute value of x less than 3. So we get x greater than negative 3 less than 3. For second inequality, we know absolute value of x less than 1. So x greater than negative 1 less than 1. We have to get intersection of these two inequalities. Let's draw a number line. X greater than negative 3 less than 3 is this. X greater than negative 1 less than 1 is this. So intersection is x greater than negative 1 less than 1. In other words, when x greater than negative 1 less than 1, then the expansion is valid.